When astronauts are on the outside of a spacecraft, it is called an extravehicular activity, or EVA. An EVA is also sometimes referred to as a spacewalk. For protection from the harsh vacuum of space, astronauts must wear a spacesuit during an EVA. The spacesuit is used in both the NASA Space Shuttle and the International Space Station programs, and is called an extravehicular mobility unit, or more simply, an EMU. Fully assembled, the EMU becomes a complete short-term spacecraft for one person. It provides pressure, thermal and micrometeoroid protection, oxygen, cooling water, drinking water, food, waste collection, electrical power, and communications for the astronaut. The EMU has 14 different layers to protect astronauts. The layers are in 3 assemblies: the liquid cooling garment to keep the astronaut from overheating, the pressure garment to retain air pressure within the suit, and the thermal micrometeoroid garment to reflect the sun's heat and stop space debris. Under the cooling garment, the astronaut wears a maximum absorbency garment, or adult diaper, to contain wastes. A hard torso is the core of the suit to which the other parts attach. A 32-ounce drink bag within the hard torso provides drinking water during the EVA. The chest-mounted display and control module has switches to allow the astronaut to control oxygen, cooling, radio, and other systems. The helmet is a clear plastic bubble that contains oxygen for the astronaut to breathe. The visor assembly fits over the helmet and provides cameras, spotlights, and a gold-tinted sun visor to protect the astronaut's vision. The EMU uses 100% oxygen instead of air. When a crew member does a spacewalk, the suit is pressurized to about 1/3 of atmospheric pressure. The amount of oxygen contained in air at this pressure is not adequate, thus requiring the use of pure oxygen. Each EMU has 2 oxygen tanks that work with a carbon dioxide removal system to allow EVAs of up to 8 hours. The Manned Maneuvering Unit, or MMU, is a self-contained backpack propulsion device that allows astronauts to venture untethered from an orbiting spacecraft. The unit is powered by 24 nitrogen gas thrusters, and its main structure is aluminum. Other elements include 2 16.8-volt silver-zinc batteries, a control electronics assembly, and 2 hand controllers. The MMU was designed to permit astronauts to perform a variety of extravehicular activities, such as satellite retrieval, science investigations and observations, in-space construction, and rescue operations. The MMU has been flown during 3 separate Space Shuttle missions. It was flight tested in February of 1984 during Space Shuttle Flight 41B by astronauts Bruce McCandless and Robert Stewart. The MMU was used again on April 8, 1984, by astronaut George D. Nelson on a mission to repair the Solar Maximum Observatory satellite on STS-41C. The third and final usage of the MMU came in November of 1984 on mission STS-51A. Astronauts Joseph P. Allen and Dale Gardner used the units to successfully capture the satellites West Star 6 and Palapa B2 and bring them back to the shuttle's payload bay for return to Earth.